Okay, so in example 9, we've been told a particle is in equilibrium under the action of three forces, F1, F2 and F3, and we have to find x and y. So it actually should have said in the question somewhere, find the value of x and y. So we have to know about a few things in order to do this question. Well, the first thing is to understand that forces can be vectors. So if I've got an object, alright, so I can say pull it to the right with a force, maybe 10 newtons to the right. I could pull it to the left, maybe 7 newtons. I could pull it down, up, alright. But I can actually technically pull it in any direction I choose, alright. Maybe, to the top right like that, or maybe to the top right with a greater angle, or maybe with a little force like in that direction, or a bigger force in that direction. I can pull it in any direction I want. And that's where vectors come into play, because vectors are essentially just arrows in any direction you want. A vector has a magnitude and a direction. So yeah, forces can be vectors. Okay, so that's the first thing we need to know about. And then the second thing is that it tells us a particle is in equilibrium. So recall that a particle is in equilibrium if the net forces, all the forces acting on an object, add up to 0. Okay? So if I add together three forces and it equals 0, it means an object is in equilibrium. So here could be an example of an object in equilibrium. So say I was pulling it to the right with 8 newtons, and these were the only forces acting on it, by the way, just these two, so ignore like weight or anything else. And say someone else was like pulling it in that direction with a force of 8 newtons. Okay. If I add together these two forces, well, this one's acting to the right, so I'd be doing 8, but then this one's acting to the left, 8 take away 8, 0. So the forces acting on it are actually 0, so this object is in equilibrium. Now, an object in equilibrium, it could be at rest, alright, but it could also be moving, but with no acceleration. So an object with 0 acceleration can still move. So an object in equilibrium is either at rest or at constant velocity, i.e. no acceleration. Okay, so let's get back to this question then. So we've got these three forces, we don't know the direction of these forces, and we do know the object is in equilibrium when acted on by these three forces. So what I'm going to do is I'm just going to go ahead and add together these three vectors. So F1, F2, make sure you underline this letter here, and F3, because that's what they've called these three column vectors. And when I do that, I should be getting 0. Alright, now let's go ahead and substitute in our column vectors. So in place of F1, I've got 40 and 2x. In place of F2, I've got y and minus 32. And in place of F3, I've got x and y. And this should equal 0, right? But the thing is, if you add together three vectors, you don't actually get a number, you actually get another vector. A vector plus a vector is another vector. So I'm not going to write 0 here, I'm actually going to write 0, but as like a vector version. So I'm going to write 0, 0 in my column vector. And so that would mean this is actually a vector here. So 0, 0. Now, the way you add vectors is, well, nice and easy. You just add the top numbers. So fancy word for that is components. So we add the top components, and then we'll add the bottom components. So if I add these three vectors together, I will end up having on the top 40 plus y plus x. On the bottom, I'll end up having 2x plus 32 plus, 2x minus 32. So this one's a minus 32. 2x minus 32 plus y. And that's all equal to 0, 0. So I've kind of got like a vector equation here, and this is pretty interesting as well. In a vector equation, if you've got two vectors equal to each other, so this counts as one vector, okay? But it's just that the top number or the top component is quite long, but it still counts as one vector. If you've got a vector equal to another vector, you can equate the components, we call it. So we're going to let 40 plus y plus x equal 0, and then we're going to let 2x minus 32 plus y equals 0. So I can actually form two equations from that. So hopefully you've spotted where this is going. So I'm going to say 40 plus y plus x equals 0, and I'm going to say 2x minus 32 plus y equals 0. and I'm going to go ahead and solve these. Now this is simultaneous equations, however we can do something to just make these a lot easier to solve. So for the first one, I'm just going to write that as, I'll just do it here, I'm going to write it as x plus y is equal to minus 40. So what I've done is I've taken the 40 to the other side and I've just put the x in front of the y, you know, like another way around. And I'm going to change this one at the bottom, I'm going to change it to 2x add y, and I'm going to add 32 to both sides. I'm going to end up with that. So you might be thinking, why have I done that? Well, the reason I've done this is because when simultaneous equations are in this form, you can simply just type them into your calculator. So if you've got the Casio graphical calculator, which I'm just going to load up on my screen now, if it lets me. If not, I'll just do it manually on my own calculator. So if I load up the Casio calculator, there is actually a simultaneous equation solver. So let's see how we'd go about typing this into our calculator. So I'm just going to hide that. So I'm going to go to the equation mode, so this orange one here. I'm going to select F1 for simultaneous, F1 for two unknowns, and here I'm going to type in the coefficients. So x plus y equals minus 40, coefficient of x is 1, so I type a 1 there, press enter. The coefficient of y is 1, so I'm going to press 1 and enter, and then the number left over on the right hand side is minus 40, enter. For the bottom one, 2, 1, 32, enter. And as you'll see, I get my two answers, x equals 72, y equals minus 112. Okay, so those are the values of x and y.